So this section here then kind of takes over where we left off yesterday, and we're looking at ratios again. They changed it over to rates, and really a rate is the exact same thing as a ratio, except for a rate has units. So rate, in the blank we have the word ratio. So it's a ratio where the two numbers have different units. So yesterday we were talking about like the guy to girl ratio or the teacher to student ratio. And you could argue guys and girls are different units, but they're both people. It's a number of people over a number of people. Here would be something like, my brother had a sailboat, so I'd scam my way on free trips. We pull it down to Key Largo and go snorkeling, sailing. So we drive the 1,541 miles. It'd take us about 28 hours. That right there, if we left off the miles and hours, so if I take and delete those off, that would be a ratio, agreed? But once we put those units on there, now it's going to be a rate. Good? So a rate is just a ratio with units slapped in there, and the units have to be different between the top and the bottom. Now a unit rate, if I were to tell you this, it really doesn't tell you, do we drive like crazy people to get down there, or were we super slow? Did we stop and have like at a hotel? Did we do long breaks? So that's where this unit rate comes in. And a unit rate, what they're trying to do, and I wouldn't write this down, but they're trying to get it where you have a 1 in the denominator. That's why it's called a unit rate, just like 1 unit in the bottom. And to do that, you just divide the numbers. So I'm going to erase that, and I'm going to say unit rate, maybe like colon or equals, and I'm going to write divide to get a number over 1. So if you were to take a calculator and do 1,541 divided by 28, in my notes I wrote down 55. So that gives me 55. And you could look at it as though it's 55 miles per hour this way. Or you could, if you wanted to extend that fraction and make it like 55 miles over 1 hour. But we'd average about 55 miles an hour. So on the highway we're going faster than that, but then you stop for gas, you stop for food. It slows down your average speed. So you could write it that way, 55 miles over 1 hour, or just 55 mi over h. You feel okay with unit rates?
Mm-hmm. Yes, sir.
Now sometimes you have a question about, now what's a better deal? So I came up with this, and you can use unit rates to figure out what's going to be the better deal. So one possibility that you could buy would be 12 golf balls for $15. Or you could buy 18 golf balls for $27. So the question is, which I'm just making this up. I don't know how much they cost, or maybe I went and looked online. I don't know. But so if we were to have that, which one's the better deal? Usually it's the 18, right? You buy more, you get a better deal. But you could check and see by making a unit rate. Now we have two options, and it's important to kind of keep straight in your mind like which one you're doing. We could do like the number of balls divided by the number of dollars. Or we could flip it and do the cost divided by the number of balls. Fair enough? If we do it the first way, what's going to be a better deal? A big number or a small number? Is a better deal more balls per dollar or less balls per dollar? More. So for this one here, bigger equals a better deal. Does that make sense to people? For each dollar you spend, you get more golf balls or more parts of a golf ball. If you do it the other way, if you do the dollars per ball, do you want to have a high number? Do you want to pay a lot of dollars per golf ball or a small number of dollars per golf ball? Small. So for this one, smaller equals a better deal. I've seen a lot of people that know the math and they do everything right, but then they pick the wrong one. And I think it helps a ton if you use the units. If you keep your units in what you're doing, that helps you see it's like, oh, do I want a big number or do I want a small number? So I can do it either way. Which way do you guys want to do it?
Balls per dollar. Bigger equals better.
Okay, so the balls per dollar?
No. Yeah.
So we'll do this one here. So for this first one, I want to make this into a fraction. If I'm doing balls over the number of dollars, do I do 12 divided by 15 or do I do 15 divided by 12? The first one, because it's 12 golf balls divided by $15. And it's different than my notes, so I need to quick punch that in. If somebody beats me to it, just holler. But 12 divided by 15 gives me 0.8. So for this one, I get 0.8 balls for every dollar. If I take and do the same thing for that second one, now I'm getting 18 balls over $27. So I take my calculator and just divide exactly like it says, 18 divided by 27. Yep, now I get 0.6 repeating balls per dollar. So which one do you want to get? 0.8 balls for every dollar you spend or 0.66666? 0.8. So the one that's a better deal is, maybe switch colors for dramatic emphasis. In this case, this one here is a better deal. If we had done it the other way around, we would have came up with, so I'll maybe write this above. I don't know if I'd mess up your notes with this, but if we'd done it the other way, we would have had $1.25, so $1.25 per ball. And we would have had $1.5 per ball. So then you look at it and say, well, do we want to pay less dollars per ball or more dollars per ball?
More.
The less is a better deal. If you make what I make in a year, you want to pay less. Unless maybe one ball is way better than the other. But 6-2. Any questions on 6-2? Cool.